Thanks everyone for joining today. Hope everyone's staying safe and staying healthy wherever you are in the world. We're really lucky today to have Patrick from the Chainlink team joining us today. So he's going to give you guys an overview of Chainlink conceptually and technically, and then actually take you through the Kaleido platform live from scratch. Show you how easy it is to actually stand up a Chainlink node, stand up your Link contract, your Oracle contract, and issue some transactions on Kaleido. So it should be pretty cool. A few quick pieces of admin for me before I punt it over. One thing we really harp on in Kaleido is that the blockchain itself is critically important. Obviously, that's our trust anchor, that's our source of truth. But when you build out what we call a bona fide full stack solution, you need a lot of additional components, a lot of these ancillary services. And this is what we've really built Kaleido to be, a digital transformation platform. So yes, of course, we have best of breed, enterprise grade, node clients and consensus algorithms for your authenticated permission blockchain, but we also give you all of those other building blocks and APIs so that you have a one-stop shop to build out your solution. And Chainlink is a perfect example here of where we're getting our data from and how that's seamlessly integrating with our on-chain business logic. So I'd say Chainlink fits very elegantly right up here, kind of in the middleware tier. So that's it for the slides today. I'm not going to go ad nauseum on them. One final quick piece of admin. All of these are recorded. So if you just go to YouTube and search Kaleido Blockchain, you'll see recordings of all of the previous Tech Tuesdays. If you want to learn more about document exchange or app-to-app messaging or all of our token capabilities or our REST API gateway event streams, pretty much every piece of functionality in the platform has now been covered on a Tech Tuesday, and we've started adding in subject matter experts from third-party services, such as Patrick, and also some of our senior engineers as well. So it's not just me, as it was some of the initial months there. Last thing, please feel free to use the Q&A or the chat. I think we have a couple folks on here to moderate, and I'll be happy to chime in as well. So without further ado, I'm going to turn it over to Patrick, who will be the star of the show today.
Awesome. Thank you so much for the introduction, Nick. And hello to all the engineers and fintech enthusiasts from the Kaleido community. So I will be sharing my screen here. Can you see that? That look okay?
Looks good, Patrick.
All right, cool. So yeah, so before going into the Kaleido demo, which we will, which is also just a fantastically simple, and we were just talking about it before, how intuitive it is. I wanted to just go over a little bit about Chainlink, a little bit about blockchain too, for those of you who are a little bit new, smart contracts and getting data, like connecting your smart contracts to off-chain data, APIs, and also traditional payments, right? The world of smart contracts is really knocking on our doorstep right here. And history is going to show, who are the pioneers to push us to this fourth industrial revolution. Kaleido has a lot of fantastic tools, like being able to spin up your own private Ethereum chain that can, really usher in this new era, right? And even if you're just using your private Ethereum chain as a database or even a decentralized network, there's so many opportunities and there's so many different things that can happen, which creativity is really kind of going to be your only limiter there. So I'll go into a little bit more of that in a bit, but just to give you the overview, first we're going to talk about the smart contract connectivity problem, how Chainlink already supports the growth of DeFi, untapped potential, and then some of the tools you can use to build some of these Chainlink smart contracts with the Kaleido Chainlink demo here. So that's basically the overview of the presentation. So in order to really understand what Chainlink is and what Chainlink does, we need to first understand that smart contracts can't actually connect to external data or any off-chain resource on their own. This is a huge limiting factor for smart contract adoption and for blockchain adoption in general, because it means the only thing that we can really do with smart contracts is token transfers. So this is cool, but it's not cool enough that we can do anything really interesting, right? And so for all you engineers out there, the question then becomes, okay, well, why can't I just make a regular API call, right? Like every other technology, you can just make an API call to get off-chain data. And this is really important, right? This is a key piece to understand. And the simple answer is that the blockchain is a deterministic system. and it needs to be validated by all the other blockchain nodes on the chain. So if making API calls is part of this validation process, then each node is going to get wildly different results in case the API is updated, change, or you call even a second later. So we can't actually work with these smart contracts the same way, you know, a Python or Node.js, JavaScript, Java, or any other language can work with this external data. And for those who don't know, you know, API calls are ways that engineers get external data into their applications. So how do we deal with this? We want to get data into our smart contract. You know, if you have your private blockchain, you want to be able to get pricing data in there. What's the price of Tesla? What's the price of ETH? I want to have an options contract. I want to, you know, keep track of the receipts for my customers. You know, whatever reason, we need to get that data into our blockchain. So the way that we work with this external data is what's called an oracle, or a blockchain oracle. A blockchain oracle is any device that interacts with the off-chain world and provides data to smart contracts. So this is the input and output of smart contracts and of blockchains. They report the result of that data on chain so that blockchains can now stay deterministic. So they actually do it in a transaction so that the validation process can stay with its whatever consensus protocol that it's using. Also, just a heads up, guys, there's a Q&A feature, I believe, with this. So if you have any questions, feel free to jump in. I will be monitoring that as well. But anyways, so that's how we can get this data in. We have to use what's called a blockchain oracle. And this is actually where Chainlink comes in. So there are thousands of APIs out there that are already providing data that people need for their applications. Chainlink makes it really easy to enable connectivity between those APIs and smart contracts, even if they require authentication. So even if you need an API key, if you need a header, you need some type of token, Chainlink makes all that really simple. And so now you can have your decentralized or centralized applications powered by the same reliable APIs that the rest of the world and the current web applications use today. And just for future reference, a single Chainlink oracle is also called a Chainlink node. I'll be using those terms a little bit interchangeably here. Now, a lot of users today still don't understand blockchain. And I know we have a diverse group of backgrounds here, and sending payments in cryptocurrencies might not even be universally accepted by everybody here. So when a smart contract has executed, people need the ability to get paid in a currency that they actually want. Chainlink makes this off-chain payments also really easy to happen based off these on-chain interactions. This also works for cross-chain communication, sending payments to other chains, and a number of other purposes as well. The way that Chainlink does this is with something called external adapters. And we have a lot of material on how to build external adapters, how to use external adapters. We're not going to go into them too much here. But if you want to learn more, you can check out the Chainlink documentation to use this. Because anyways, I mean, even if you don't need authentication, Chainlink makes it really easy to connect to any open API or a payments API or any other blockchain. External adapters are kind of this key piece that allows you to do this off-chain computation, this API authentication, and a lot of other interesting things so that your smart contract can do whatever you want it to do. This is really the crux of the customizability. It allows you to do whatever you want with this data, and can even save you a lot of gas for those of you who are familiar with transaction gas and how this works. But anyways, external adapters are basically wrappers around another API. And that's how they make it so easy to provide authentication, processing, and anything else that you want to do. External adapters are really the piece that makes it really easy to introduce new functionality to Chainlink without needing to know anything about Solidity or even Ethereum, since you can write these in any language that you want. Now, here's where things get a little bit interesting. And it might not apply here as much when spinning up private blockchains. However, if you're going to take your private blockchain and you want to, move it onto a decentralized platform, or you want to make a decentralized platform in Kaleido as well, this is something really important to think about. Whenever you're making a decentralized platform, the purpose of you making it decentralized is so that it has no single point of failure, right? There's no one entity that you ever need to trust. And if we have a single node or a single centralized node, we now have to trust that this node is going to provide data to us in a reliable manner. In the same regard, if we have a single data provider or a single data API that we're relying on, now our entire smart contract is going to rely on those data providers. And this even applies a little bit to your private blockchains. If you have a single node that is streaming all your data and that node goes down, you want to have redundant nodes, right? So it applies both to centrality and, obviously even more to decentrality, because if you're having these decentralized applications, you need to never have this single point of failure. And this is why we create decentralized oracles. So just a common misconception too, saying a Chainlink node by itself is decentralized is sort of like calling one tree a forest, right? Doesn't really make sense. One single entity doesn't make up a whole. To make applications that truly never need to rely on one entity, be it a company, landlord, government, or anything of the sort, you need a network of Chainlink nodes. The reason why I'm stressing this point is there are a lot of decentralized projects that have already been attacked because their oracles have been centralized. So their centralized data provider was hacked, flash crashed, updated, and the project didn't catch it in time and they lost a lot of money. So Chainlink is designed to be this modular infrastructure and can build a decentralized Oracle network used to connect smart contracts to any API. You can select as many Oracle nodes or Chainlink nodes, again, as you like, and use as many data sources as you like in order to trigger the execution of your smart contract and keep them decentralized. Then again, Chainlink also enables off-chain payments to occur based on the execution of a smart contract. Excuse me. So if the result of a smart contract said, Bob needs to be paid $100 in USD, you can utilize Chainlink to send that transaction from cryptocurrency. So to get you started in DeFi, the Chainlink project has gone ahead and found many of the best blockchain node operators on the planet and combined their prowess to build what's called price feeds. These are decentralized on-chain reference points that can be considered source of truth for various currency pairs, like the price of ETH in terms of USD, for example. Each node in the network independently gets data from some of the highest quality APIs and reports their answers on-chain. You can see the answers that each provider reports, so everything is transparent. Many of the most popular currency or fiat currency pairs are currently supported. And one of the best parts is if you don't like the network or you want to use your own network, Chainlink gives you that freedom, gives you that customizability to do that and do whatever you like. Because as we were saying before, you can call any API, you can call any group of APIs through any number of Chainlink nodes that you specify. So it's entirely customizable, which is fantastic. Currently, though, these price feeds are already being used by many of the top projects in DeFi in the world. The proven safety, reliability, and power of these applications is a testament to the power of Chainlink and these price feeds. So here's a quick snapshot of, and then again, DeFi is moving so fast, so it's probably already out of date. The top 5 projects in the DeFi space, Aave, Maker, Curve, Synthetics, and Ethereum.finance, 3 of which are using Chainlink price feeds to power their applications. So these Chainlink price feeds are securing, the numbers are right there, literally billions of dollars. So that's just a testament to how reliable these are. And then here's a couple of the products currently working with it. We have Synthetics, which is 900 million in assets under management, Loopring 20 million, Set Protocol another 20 million, and Aave 1.5 billion. With a B. So there's some pretty large projects out there being secured by these Chainlink price feeds. Chainlink also has this utility for creating random numbers. This is called the Chainlink VRF. And these are provably random numbers. So that's something that the current blockchain actually can't do because blockchains are deterministic systems. Right? So this means that everything that happens, you can calculate what it'll be. So if you can calculate something, it's not random anymore, right? So Chainlink VRF is a way to get a provably random number into your smart contract so that you don't have to depend on these calculated or these pseudo-random numbers where somebody could come in, hack it, and do something bad. So we're seeing more and more adoption from different projects using this Chainlink VRF. Some of them are on screen right there. Pool Together is one, and they have about, the last time we checked, 800 1,000 worth of DAI in their projects and constantly growing. So we're seeing more and more adoption for getting these random numbers as well. So, getting a random number, working with these price feeds or connecting to any API, the sky is really the limit when it comes to the creativity of the different applications that you can build. So there's a ton of projects that haven't been built and that can be built. And Kaleido actually, again, makes it really easy to get a lot of this stuff spun up and start building, some of these ideas. So if somebody you are strapped for ideas a little bit here, this kind of brings me to my next point. We have a blog out. It says 44 ways to enhance your smart contracts with Chainlink. These are just some really quick ideas. If you're like, hey, I want to do something with this cutting edge technology. I want to do something really cool, or maybe you want to branch out, or maybe you didn't think something was possible. These are some of the things that are possible out here. So decentralized finance and even centralized finance, getting this financial data into your blockchains, into your smart contracts is super easy with Chainlink. And right now, if we look at kind of traditional finance, it's between 3 trillion and 100 trillion, right? There's a lot of money with asset managers. And right now, DeFi is about 10 billion, 9 billion. So the market is there, right? The market going from these traditional finance to this new era of finance is there. And we're slowly seeing more and more adoption, which is really exciting. Fantasy sports or any type of gaming applications, you can hugely cut down on every type of overhead cost, and make these platforms fractions of a fraction cheaper. Texas Hold'em being another one. Chainlink VRFs make it possible to get these random numbers into your games, but while still being way cheaper than any traditional tournament. Tokenized assets is a huge piece. You can split up your car, plots of land, shares of stocks, make it really easy to track of who owns what without having to deal with any of this paperwork, right? You could have a blockchain that literally just says, hey, these 4 people own this house, and you don't have to pay a lawyer to deal with all these fancy deeds and whatnot. And if you guys are interested, you should check out Open Law. They make a lot of that legal to blockchain work really easy too. But yeah, and since your data is going to be coming from decentralized oracles or Chainlink oracles or these reliable sources, nobody can mess up your contracts here. Insurance is a huge one that kind of hits home a little bit. Let's say your crops get all messed up due to the weather and the insurance doesn't want to pay out because of some pre-existing condition. With a decentralized smart contract, you don't have to trust that the insurance provider is going to do the right thing, because the right thing is infrastructural with Chainlink. And this is a huge draw for customers to use this smart contract that they don't have to trust, that the entities who are providing it will or won't pay them out, right? So there's mind-blowing potential here. So with that, I wanted to take a quick pause and ask if there were any questions on Chainlink and some of the features. And I know there's a lot of different backgrounds here. Some people are engineers, some people have, probably only heard of what Ethereum is, but yeah, feel free to ask any questions.
We subscribe to the there are no dumb questions philosophy.
Yes.
So I know it can be intimidating, but don't be shy to use the chat or Q&A, or if you're real brave, you can raise your hand and speak out loud.
All right, if there are no questions, then maybe I'm at an impasse with connecting my setup with the member interface. Can you reiterate? Maybe that's out of scope of this meeting. We have one question. Can you elaborate on the business model? So yeah, so I can elaborate on the business model. Yeah, so let's even scroll back a little bit. So you need to keep in mind that Chainlink is a technology, right? Like Linux, like Python, and it's something to use for whatever you want. So the business model is really going to be kind of whatever you make it out to be. Running a Chainlink node, the business model there is you're providing this Oracle service to deliver data from off-chain to on-chain. Now you can run your own Chainlink nodes, but what a lot of people will do is they'll use other pre-established nodes. That way, their team can focus on, whatever it is that they're good at: insurance, fantasy sports, DeFi, whatever, right? And they'll let the Chainlink node operators run the nodes, and they charge like an Oracle. So when you make a transaction on Ethereum, you pay a little bit of gas. This is your transaction gas. Oracles do the same thing. They just charge an Oracle gas fee, which is the Chainlink token. So that's kind of the business model behind running a Chainlink node. And that's actually a really good point, because it's important to note that running a Chainlink node isn't like running an Ethereum node or a Bitcoin node. You can't just spin one up and start mining right away. It's really a digital business, right? And it's going to be up to you to decide, okay, my node is going to provide this special data, or my node's not going to provide this data, or my node's going to provide this service. And so that's some of the advantages of running your own node and making it public. Or you can just run your own node in your private blockchain, which we'll show you in just a minute, and how you can use that to get data into your blockchain, into your Ethereum node for whatever business purpose that you have. Maybe you need to do like KYC. Maybe there's some type of private data that you need on your own private blockchain. Then you can just run your own private Chainlink node to get and request data. So that's a really good question. All right, cool. There are no other questions. I'm actually going to jump into the demo here. Cool. So this is Kaleido here. This is a brand new instance that I just spun up today. So I'm glad Nick's here to help me out in case I mess anything up. I know the Chainlink stuff really well, but luckily everything's super intuitive here. So what we're going to do is we're going to create our own private Ethereum chain. And then we're going to use a Chainlink node to get data from an API. We'll even show you what the API does from the real world, into our private chain. So another question: do you have to license the node from Chainlink? How does Chainlink make money? So again, Chainlink is an open source. It's an open source technology, right? So asking how does Chainlink make money is kind of like asking how does Linux make money, right? It's an open source technology. No, you can just do it right now if you wanted to. You don't need to ask permission. It's it's like Linux, it's like Python, it's like it's like every open source technology out there. That's a good question. All right, let's create a network, and we'll call this Chainlink demo. Network mission statement to show the awesome power of Kaleido and Chainlink. Great. Where do we want to be? Let's go to Ohio. So this is choosing our AWS region. This is where our servers are going to run. We're on the free tier, so we're just going to choose one here. If you for more production servers, you're going to want to get redundancies and stuff, but I'm not going to go into that too much. We're just going to stick with Kaleido, or excuse me, with Ohio. And cool, now we have our dashboard. So we're going to add an environment here. So this is going to be, we're going to add our Ethereum environment here. So this is our Ethereum node, which is going to be running in Ohio, which is really cool. And I believe we chose AWS. So we're running our own Ethereum node on AWS, which is really exciting. So let's get one set up. It's super simple, which is really exciting. We're going to call this ETH node cloud only. Yep. And this doesn't really matter so much. I think Quorum was the popular one. Is that right, Nick?
Yeah, so for the majority of, I'd say, production enterprise use cases, we're seeing either Quorum or Besu, mainly because they both support IBFT and they also support private transactions. So it's a nice way to kind of future-proof your, I guess, your business logic and your overall network.
Gotcha. Okay, we will use Besu though, because it has proof of authority. Great. For those who don't know what the different kind of consensus protocols are, like proof of authority, check it out. Basically, proof of authority is saying, we get to choose what finality on our blockchain is. So great. Now we can check out So now we have our dashboard for our Ethereum chain here. We can check. We can add a node here. Oh wait, did I already add a node?
So what Patrick did is he created an environment, and an environment is essentially just a namespace or a wrapper, and then inside of it, we're going to actually stand up blockchain nodes that are going to run the client and consensus algorithm that he just chose.
Great. So we're going to spin up our first node here. I'm going to skip all this because I don't care. Just for the demo, it's going to be a small node. And cool. Okay, so we have our first node here. This is a little confusing. I called it Chainlink node.
So if you just click settings, Patrick, you can just name it blockchain node. So in the left dashboard, right down there, right above logs.
Okay, cool. Let's change that. Thank you. All right, cool. We're going to call it blockchain node. Awesome. So this is our first node. We're going to add another node because you never want to have a single node. So we're going to call this blockchain. I should spell it right. Blockchain node 2. Cool. Let's skip all this. Small. Great. And cool. So now we have 2 nodes, and we can see our 2 nodes kind of in this environment dashboard here, which is really cool. They're still it's still initialized, still getting set up here. But these are going to be our 2 nodes. Obviously, like Ethereum mainnet has thousands of nodes, probably more than thousands of nodes. But for our demo, we're just using a private blockchain, so these are going to be fine. These 2 are going to be fine. So what we want to do now is we want to spin up our Chainlink node. So we're going to add a runtime. We're going to call this Chainlink node. And we're just going to wait a little bit for it to get set up, but that's it. Like you really just click, add Chainlink node, add blockchain node to make your blockchain as big as you want. For our purpose, we're only going to use one Chainlink node. There will be different reasons for you to have many many Chainlink nodes in your own private chain. One of them being having redundant systems, which is really important for just testing and for playing around. One is more than enough. So once it finishes spinning up, we will be able to open the web UI, but we're just going to give it a minute here to actually get.
As we're waiting, Patrick, if you click dashboard in the top left, we'll actually be able to see the status of everything inside of our environment. So there we have those, and now we can see the macro view of, we have our blockchain nodes, we have our indexer, our system monitor, and then boom, now our Chainlink guide just came alive.
Perfect. And then we can even look at like the stats of our blockchain node, connect API here. We're going to need this in a minute, and I'll show you why. But yeah, you can see your entire blockchain network is here, right? So let's go into here. Let's open the web UI, and this is the I forget what the password is.
So it's there for you on this page. Yep.
I believe it is. Aha. So we have our username and password. Perfect. Username, password, and I'm very familiar with this. So great. So this is the web UI of your Chainlink node. I'll give kind of a quick rundown of how it all works. For our chain, this might not get updated, but whenever you run your node, you need to fund it actually with ETH, so that I can do the gas costs. On our private chain, the gas price is actually going to be 0, so we shouldn't have to fund it here. But this has all your stats. It'll show you what your account address is, where your port is, your ETH URL, all your transactions, which right now we have none. Don't worry about bridges for now. This runs page is going to be all the runs that connects our node to our blockchain, and then jobs. We'll get into this in just a second. So the first thing that we can get into it now. The first thing that we want to do is create a job. Now, a job is going to be what allows our smart contract to actually call the Chainlink node. So actually, we do need to deploy a smart contract here. So we need to pull up Truffle and deploy that on our Chainlink node first, or deploy deploy that on our smart contract. So the first thing that we're going to do is we're going to deploy a smart contract, which is really simple. Let me switch screens here. Get out of my other editor. Share screens. Okay, cool. So this is going to get a little bit technical here. This is all the code we have to kind of go through this demo here. So the first thing that we're going to do is we're actually going to deploy. We're going to deploy a smart contract that I believe it just gets. Let's even just check. Yeah, it just gets the price of a ticker, and we can even see what this is. Let me switch screens back here. It's just going to get the price. It's going to get this last price right here, right? So this is what we're looking to get. We're getting it from this Bitstamp API, which again, APIs are just easy ways to access data across the internet. So let's flip back to this. And then I just did this right before this. So we're going to need these two environment variables. We're actually going to need 3 or 4. We're actually going to need 4, but we'll go into that in a second. So the first 2 that we're going to need is this link contract address, which is the address of the Chainlink contract. We don't really need to worry about that, but this Oracle address is the address of the Chainlink node that we just spun up. So if I flip back to, I'm going to be flipping back and forth a little bit, huh? If I flip back to Kaleido, I can actually get those from our Chainlink UI right here, right? So we have this link contract address. So I'm actually going to copy that. I'm going to export it here. I will show you what I'm doing in just a second. Link contract address equals. Now I'm going to flip back. I just want to do it that first time there. And then we're also going to take this Oracle contract and we can just do export.
I think it's just link underscore address. We got to get the
it is.
right.
Yep, you are correct actually. Export Oracle address equals this. So let's do export link address equals this. And so these are our environment variables to get this to actually work. So now we have these 2 environment variables set. The next ones that we're going to need are these 2, and I'll get into what those are in a second. Can we actually deploy? No, we have to. Nope, we do have to set them right now. So the ETH-URL, this is what's going to connect our local instance to the blockchain that we just spun up to our private blockchain. So we're actually going to deploy a smart contract to our private node. We're going to deploy this contract right here. For those of you who know Solidity, oh no, I'm mistaken. We're actually pulling from Crypto Compare. Unless we have 2. Are these 2 different contracts? Oh no, it looks like we're just pulling from Crypto Compare. I take it back. Sorry. So we're going to be pulling from Crypto Compare. We're going to be pulling from Crypto Compare and getting the price in USD, which is cool. So we do need this ETH-URL though, and again, I'm going to be flipping back a little bit. So we come in here and we can find the URL.
So let me help. So click dashboard.
Yeah.
And then click the node you want. Yep. And then connect app in the bottom right.
There it is, connect app. And we're going
So what he's doing now is he's creating application credentials. Every service and every node in Kaleido, we enforce boundary security. So you need this secure TLS connection. You need that handshake, and we authenticate with strongly generated what we call application credentials.
Awesome. So we have these application credentials, and we're going to use this RPC HTTPS endpoint right here. So we're going to copy this, and we're going to flip back over, and we're going to do export. And just so I make sure I do it right, export ETH-URL equals this endpoint. Looks good. And then the last bit is this job ID. Now this job ID is what's actually going to define how we get this data and where we get this data. So in our repo, we have like a nice little jobs here. We're going to copy it. we're going to go back. Excuse me. We're going to our Chainlink node. So let's go to, this is our ETH. Yep. Go back to our Chainlink node, which is it in here? Dashboard? Oh, maybe it's taking a second. Start a Chainlink node.
We just need to get back into the operator UI so we can create the job and the job ID. That's the
Gotcha.
variable.
Yeah, I was looking for the the button to open the web UI again. So cool. So now we can post the job in here. And again, these are all the different adapters. If you want to learn about how adapters work, you can check out the Chainlink documentation. You don't need to worry about it too much right now. We're going to create the job, and now we have this new job. So if we go to our jobs list, this will be the job that we just made. And again, it's going to be doing an HTTP GET, and it's going to be pulling the price. Our smart contract, it actually is going to override some of these parameters in here because we specified. Oh, I'm showing the. I was just showing VS Code instead.
Great.
Yep. Sorry, guys. I went to jobs, new job, pasted in here, and that was the job. So, but we're gonna leave. So yeah, so this is our job. Our smart contract is actually going to override some of these values that we put in here. So cool. Now let's flip back to VS Code. Sorry about that. Now let's flip back to VS Code, and I believe we're actually all set up. We're going to create the Chainlink node in a Kaleido environment. Yep. Create a job. Yep. Set the 4 env variables. Did we do that? We sure did. And then we just have to run npmi. This will install all of our packages so that we can actually run Truffle. And Truffle test will actually deploy our smart contract, which again, our contracts are all in here. We can see here, we're going to use this URL instead of that URL that's in the job. This right here for the Solidity buffs out here, this is kind of the main function that allows us to pull data from a Chainlink node. It's this, we build our Chainlink request. We specify the job ID, which we get from our Chainlink node. We specify the address that we want the data to come back to, which is this. In this case, it's this. We want the data to come back to this smart contract. And then we choose the method that's actually going to fulfill it. So if we look down, there's this function, fulfill Ethereum price right here. And it's saying once the Chainlink node makes the request, it's going to bring it back on chain with this fulfill Ethereum request. So the Chainlink node is actually going to call fulfill Ethereum request. It's going to send the request ID, and it's going to send the price here. And then once it's back on chain, we're going to set the current price equals to that price that we got from the API call. So these are the two main functions that we care about. This one builds it. And then here, once we create the rec object, this is where we add basically the parameters of the request. So to our get, we're going to add the URL. This is the endpoint that we want. Path is actually going to be the JSON that we're going to walk down in this URL. So if let me flip back over again. So this is the JSON that this API is going to return, right? It's returning USD 341.2. So we actually just want to walk down. We only want this 341.2, right? We don't want this whole object. So path is just saying, hey, get whatever the USD key is returning. Let me flip back. It looks like our stuff is just about finished. And then the last thing that we do is we times by 100. So Ethereum can't actually work with decimals very well. It doesn't work with decimals very well. It doesn't work with fractions very well. So we need whole numbers. So we multiply it by 100, just so that we have a whole number there. And then we can just run, just make sure I have Truffle installed. Cool. And then we just run Truffle test. And this will actually spin up this smart contract here. Well, spin up this smart contract here on our private ETH chain that we just spun up in Kaleido, which is really exciting. And yeah, the main functions that we care about are are this request Ethereum price and this fulfill. So we're just going to give it a second here to do its thing. There's some other functions in the smart contract that we can kind of ignore for the bit. You know, get Chainlink token is just going to return the address that we just put in. Withdraw link. So in order to make Chainlink calls, you need to pay that Oracle gas that I was talking about. If you send a bunch of link token to this smart contract and you want to withdraw them, you want to take them back out, you just call this withdraw link function. Cancel request, cancels request, and this string to bytes 32 is kind of just a helper function. If you input your job ID as a string, it'll actually just convert it to a bytes 32 object. So we're just waiting for it to connect here, and maybe I'll redo these. Did I actually do the job ID? I don't know if I did the job ID. Let's see if I can just export. Let's just redo these just to be certain that I have everything right here. Export link address equals this. Export Oracle address equals this. And then we're going to grab JSON RPC, export ETH URL equals this. Maybe I just had one of those wrong. Now it's trapped.
The ETH URL needs the application credentials inline, so that's not going to connect,
yes.
Patrick.
So that's probably
I'm wondering too. Don't we need to fund the link address with some link, the Chainlink node address?
Actually. Yeah, that's a good point. So this one's correct, right?
Nope. So that's just kind of like the core RPC endpoint. We need that username :password at that endpoint. So if you go back into your node and just click connect app again and create a new set of app credentials.
Right. Yep. That's right. Reuse existing. Yep. Connect.
So let's do that, and then let's fund that account, and I think we'll be hunky-dory.
Yeah, I forgot the gas price is 0, but the link token is still a thing. So if I go to connect, oh no, I don't want to do that.
Just click regenerate password.
Generate. And
now that fully qualified string, yep, JSON RPC over on the right.
Great.
That's our guy.
Awesome. I'm going to export this. I don't know, you guys can't see it.
And I know every developer out there has sincere empathy because, you know, live demos, this proves that it's real technology here.
All right. It's because, because we have to go back and touch stuff. But yeah, so let's go back to the Chainlink node. Chainlink demo dashboard.
Okay, so yeah, so if you just click there you go.
And then
your node on the right.
Actually have this open. But yeah, I want to fund the node, other runtimes, this one.
Fund account, the top.
Yep, that's right. Fund account. We're going to fund it with link.
It auto populates it, so we just need to select the amount.
And then let's give it 100. That should be plenty.
And now inside of the dashboard, he'll actually be able to see that inside of the Chainlink UI, the fact that it was funded. So we see if you hover over that, yeah. So it's specified in 18
Okay.
decimal places. So.
which is a lot. So cool. All right. So now we have it funded. Sorry about that, guys. Now we have it funded. Now let's flip back over. Now let's run this. Because now our account actually has some link token. ETH gas fees are 0. So that shouldn't do anything. That shouldn't matter. And we should see a runtime pop up once this actually gets deployed. It's stuck somewhere. development, yeah.
Patrick, are you in the right directory? Are you in the V5 directory at the moment?
Yep, there we go. Okay, all right, cool. Couldn't connect to node. HT, well, that makes sense because export ETH URL equals this.
Hooray!
Nice. All right, cool. Sorry, I was in the wrong directory. Whoops.
So the README that Patrick's following along with, you can find this in our documentation if you just go down to the Chainlink service in docs.kaleido.io, and it holds your hands. And I think Patrick's even submitted a PR to kind of clean it up just a tad and make it a bit easier for, especially for the devs, just putting those environment variables up front. But we can see here that, once you get your strings and your variables right, it's about as trivial as pressing truffle test, and all that's handled under the cover.
Yeah, cool. So this deployed our smart contract to our private blockchain on Kaleido, and now we can actually interact with it. So we view, is this the node that we user accounts? Actually, let's just look at both of them. Why not? Which node did we actually play with?
So we're still only seeing your VS Code, Patrick.
Oh, whoops. Sorry. So here are our two nodes. Let's go back to the dashboard. We have these two nodes, and one of them is the one that we deployed the smart contract to.
Yeah, so if you click dashboard again, and you expand the environment drop down, we'll see this data explorer. And this is going to give us rich metrics, and it's going to let us see all the things that Patrick just did. So here we have the high level macro smart contracts, our link token smart contract, our Oracle smart contract, our proprietary business logic that is chain linked, and a few others there. And then in the block explorer, we can actually inspect specific transactions that have taken place inside of the network.
That's right.
And you could start marrying these with the accounts on the node that we use to sign those transactions as well. So all the data is available for you to kind of peruse and create those relationships.
Yeah. So this is like the ether scan of Kaleido, which is really cool. So yeah. So if we go back to Data Explorer, Smart Contracts, we can see, okay, cool. So these are the two, and we can see this is our address here, and these are the two contracts. It looks like we deployed two contracts. Let's do the second one. And this shows like the actual execution, like all the everything you'd find on Etherscan, which is really exciting. So now we want to interact. We want to call the API through this smart contract. Oh, excuse me. We can see that when we deployed it, it actually made this API call, and we can see everything here. So it actually, so it called, oh, it didn't overwrite it. I take it back. So it called this API here, and then it followed the JSON path to get this variable, and it multiplied it by 100, and then just converted into like the blockchain readable version of it. But we can see this, we can see all of our runs in our Chainlink node. So we can see everything that's actually happened. And then I'm even going to run it again. So you guys can't see my VS Code, but I'm hitting truffle test again, which should deploy another contract on V5. And then those contracts are making the call to this API, which is really exciting. And if we wanted to even mess around, we could change the job spec a little bit. We could change it so that it's not actually hard-coded in those, hard-coded these in, and we can actually get parameters. So your smart contract can actually be the one to input whatever you want. So actually we can see it pop up. I just hit truffle test. It's already pending confirmations. You'll see this a lot. It means like it already made the API call, it already transformed the data, and now it's actually posting in the transaction back on chain. So this ETX adapter is the, Ethereum transaction adapter, and this is the one that actually posts stuff back on chain. And same thing, we can see that it actually worked here, which means that our smart contract that we just deployed, if we go back to the, let's just go back to dashboard. Dashboard smart contract. The smart contract that we just deployed is also deployed here, and it looks like I got my session expired. Whoops. Well, that's perfect timing because that was the demo anyways. But yeah, with that, I'll put the repo up here. This is the repo. Oh, this is my version of the repo. But yeah, it has everything you need to know to like get any data into your private Ethereum chains. And that's where the real power comes here. You know, you can get your smart contracts, get your Ethereum chain to do whatever you want it to do. And this is also a way for you to interact, not only get data, but also you can do HTTP posts, patches, you know, whatever you want to do. It's also a way for your private chains to interact with the outside world. So we'll jump into questions now. Hi, is it possible to get this demo version for mock drills of creating a private blockchain for tokenized assets creation? This demo version for mock drills of creating a private blockchain for yes, I think the answer there is just yes.
Yeah, sure. Yeah, well, I'll answer with you alongside with you, Patrick. It's free to sign up for Kaleido. It's free to do exactly what Patrick did. It's free to spin up a Chainlink node. And we have open sourced every single piece of business logic, Solidity, JSON, and truffle configurations that you need. So yeah, you can take this as your baseline, as Patrick was just mentioning, and then based on your organizational requirements and your use case, start tampering with the API call. Go to a different place. You can do a post, you can do a Git, and you can configure this, you know, bespokely to your own use case and your own business needs. So yes.
Yeah. So yeah, as you just said, the instance that I just used, I literally made it, you know, right before this. So it's free to make, it's free to test out. This is an open source repo. You can Google it, you can find it, and start getting data into your own private blockchains. So absolutely. Yeah. Any other questions here? Awesome.
Cool. Well, it looks like there's no more questions. We'll try to give everyone 5 minutes back. Thank you, Patrick, so much for teaching us about Chainlink. Like I said at the beginning, it's really, really awesome to get subject matter experts on all the different components and all the different services. So that was very, very edifying to me to get your insights into this. So many thanks. Thank you everyone that attended today. As I said, it's free to sign up, so don't be shy to go to console.kaleido.io and just create your own account. You can mess with our services, mess with, you know, all the open source repositories, and you know, get started with your own private permission blockchain. I'm going to throw my email into the chat in case anyone has any technical or commercial queries. And then, like I said, this is recorded. We'll be emailing out the recordings, and then next Tuesday we'll have Jim Zhang, our protocol lead, joining us to show you how to use how to do upgradable contracts with a proxy contract. Pretty useful stuff when you realize that your business use case is gonna, you know, not remain static, you know, over the course of a year or 2 years or 3 years. We're in a dynamic space here. So many thanks, and it looks like Patrick is.
Yeah, I just put a link to the Discord in there too. So so when it comes to the Chainlink pieces, you know, obviously that's where I can help you guys out. So if you have a question about Chainlink, it's more specific to actually how Chainlink works too. You know, that's the developers Discord that I just put in the chat there. You know, feel free to jump in, say hi, you know, show off what you've made, say, hey, you know, I made this awesome piece with Kaleido and Chainlink. You know, we'd love to see it. We'd love to help out and say hi. So.
Sweet. All right. Well, thanks again, everyone. Hope you stay safe. Hope you stay healthy. And one last thanks to Patrick for joining us today. And I wish everyone a fantastic remainder of their Tuesday.
Awesome. All right. Thank you, everybody.